So what would the number of heads likely fall between?
45 and 55.
Right, 45 and 55. Is likely that the number of heads would be between 45 and 55, or 50 coin tosses.
Way over 100.
Oh, for 100, yes. Boy, that'd be bad to get 55 heads on 50 tosses. Okay. Just translate, what percent would be heads then? What would our percentage range be for the number of heads on 100 tosses?
55%.
Right, 45 to 55. As a percentage, this is 45% to 55%. Okay, so basically 40, while it's possible, is not likely. Okay, that's not going to happen nearly as often as the result between 45 and 55. Okay. If you turn over to that, I'm going to look at theoretical probability and experimental probability. You know, this is something that is easy to get the two mixed up. Okay, theoretical probability, basically you're using the properties of the experiment. So that, for example, the coin toss one, theoretical probability of getting a head on a given toss is 1/2. One head, two sides. The experimental probability would be, let's say Mason decided to flip a coin 10 times, we got 6 heads. His experimental probability of getting a head would be 6 out of 10, because he actually did the experiment. He took the total number of successes divided by the total trials. In sports, you see experimental probability all the time. Okay, free throw percentage. Somebody's a 90% free throw shooter. The idea is they have a 90% chance of making the free throw based on the fact that they've made 90% of their previous attempts. They actually shot a bunch of them and they made 9 out of 10. So the theoretical probability is defined as the probability of A is the number of ways for event A to happen over the total number of possible outcomes. Remember that absolute value was kind of a counting thing. It counted the in this case, the number of elements in a set. So it's the number of ways for event A to happen. And the absolute value bar around the S. S is usually used for sample space. Okay, sample space is all the outcomes. Total number of possible outcomes. So, as an example, probability of getting a head is 1/2. And it's just based on, again, the properties of the experiment, of the thing you're doing. Experimental probability is basically probability of A would be the number of successes of A over the total number 6 heads and 10 tosses would mean your experimental probability is 6 out of 10. Because you actually tossed the coin, and that's how many times it came up heads out of the total number of tries. You know, as you can see, obviously the experimental probability can be different than the theoretical, but as you did it more and more and more, it's going to get closer and closer and closer to that theoretical probability. If you did it an infinite number of times, it would be the theoretical probability. Another example, sports is full. Free throw percentage, batting average, experimental probabilities are used a lot. They would play a large role in like insurance premiums. Why do you think younger drivers have higher insurance rates? More crashes. Why do you think males usually have a higher insurance rate than females? More crashes, okay. Because over time, the data has been compiled and calculated the experimental probability of accidents and paying out and how much it's going to be and those kinds of things, all factored into creating that insurance premium. So your key in your book, add this in a little note at the theoretical probability uses properties of experiment while experimental probability uses actual results of the experiment. What I want you to do is switch partner, figure out the last one. How many heads would you expect to get? And then what percentage of the time would you expect to get heads, like we did with the first one, we made it 45 to 55% of heads for 100. Do the same idea with